Welcome to another exercise in this workbook, Statistics. This time I'm going to focus on calculating measures of dispersion for unclassified data. So here my data set is about a farmer who sells his vegetables at a weekly market. His revenues during the 10 hours he spends at the market are as follows. And we get this data set with 10 observations. And we have 4 tasks surrounding this data set. First off, calculate the range of the data set. Then calculate the interquartile range, calculate the corrected variance, and build on this, calculate the corrected standard deviation. Well, before we start with all of this, I'm going to just rearrange my data set because this will make part A and part B significantly more easier. So I'm going to take the original data set and I'm going to order this in an ascending fashion. So I'm going to start with the smallest values and going to increase them continuously, always the next largest value. So at the end I have this ordered data set starting with the smallest until the largest. So this is really good because this allows me to directly see minimum, maximum, and might also help me get a median or some other statistics if I'm interested in. However, I want to calculate the range first, and the range is nothing else than the difference between maximum and minimum, or last and first value of this ordered data set. So here I can simply get first and last value giving me 800 and 200, so I have a range of 600. I'm already finished with part A. Similarly, I'm going to use the same data set in part B because this will also be much easier if I have this ordered data set. So I'm copying this ordered data set, and next I have to calculate the interquartile range. The interquartile range, I can imagine this as the height of the box plot, whereas the range is the full height of the box plot from lower to upper whisker. The interquartile range is lower bound of the box to upper bound. And this is third quartile minus first quartile, or 75% percentile minus 25% percentile. So how do I get these percentiles or quartiles? Well, I'm going to multiply those percentages with the number of observations. Here I have 10 observations, so I'm going to multiply 0.75 times 10 and 0.25 times 10, giving me 7.5 and 2.5. If those two values are integers, then I have to use a slightly different formula. As long as they are not integers, well, as the case is in both situations here, I can simply round them up. And I'm always going to round them up, independent of what's after the decimal point. I'm going to round both up. I will get 8 and 3. So I'm looking up the 8th value and the 3rd value in my data set. And I'm going to subtract from the 8th the 3rd value, giving me 300. So my box of the box plot has a height of 300. Well, that was already part B. That was the interquartile range. So we are left with the 3rd and 4th part, which are pretty close connected. So I need the variance first, and to calculate the variance, I first get the arithmetic mean. So the arithmetic mean, that's simply adding up all the values, dividing this by the number of observations. Since some of the values are present more than once, I can shorten this down by simply going 2 times 300, 3 times 400, and so forth. This yields me a mean of 425. This I'm going to use if I actually calculate the variance, because the variance, well, I have different functions for this. Here I'm going to use this formula, which is just, first off, squaring all my original values. So everything I have here to the power of 2 and summing this up. So this is pretty similar to what I did before. And I'm going to divide this by the number of observations minus 1. So this is like the corrected arithmetic mean of x squared. That's the first part. And I have n minus 1 because I'm talking about the corrected variance. From this, I'm going to subtract here the arithmetic mean to the power of 2. That's why I needed the 425 at this point. And I'm going to multiply this again with a correction factor, which here is n divided by n minus 1. So in this case, 10 divided by 9. If I'm inserting all of this, we can see here that's the first part in those brackets. That's all the values squared and added up, divided by number of observations minus 1, divided by 9, minus 10 by 9. That's those two parts, and the arithmetic mean squared. That's this part. I'm going to put all of this in my calculator, yielding me a corrected variance of 35,138.89. Well, that's already the variance, so getting the standard deviation in part 4 is actually pretty straightforward as well. Because for the standard deviation, we're just going to copy the variance from the previous part, and we're going to get the square root thereof. Because standard deviation is nothing else than the square root of the variance. So here I'm getting a standard deviation of 187.4537. If I use the corrected variance, I'm also getting the corrected standard deviation. If I'm using the uncorrected variance, I'm getting the uncorrected standard deviation. So here at this point, I do not have to make any additional corrections. This already works out decently well by just using the corrected variance I calculated earlier. And well, that's already everything there is to this exercise. So I hope you enjoyed it. I say goodbye and see you next time.